Hello everyone, my name is Brian Ponciano Leiva. I'm a master's student in science physics at the Autonomous University of the State of Mexico. Today I will present to you my work entitled Insertion of GO particles into silicon oxide using a plasma system technique. I'm doing this work at the Institute of Physical Science of the Autonomous University of Mexico. This project focuses on leveraging the unique properties of graphene oxide, such as its high conductivity and two-dimensional structure for optoelectronic materials or optoelectronic applications. The substrate we use is silicon oxide due to its stability, abundance, and widespread use in the semiconductor industry. In fact, silicon is the most widely used material for semiconductor applications, such as solar cells, microchips, and more. To perform the GO deposition, we use plasma techniques, which allow us to modify the silicon oxide surface without using aggressive solvents, thus promoting coating adhesion. The work was carried out in two stages. The first one, a plasma treatment at atmospheric pressure was applied to activate the surface, and then the GO was deposited by drying. The setup is shown in Figure 1. In this case, we use a high power source connected to the electrodes to produce the discharge on the silicon wafer surface. Atmospheric pressure is used in this part, so there is an airflow. The sample was then subjected to low pressure plasma in two different atmospheres, oxygen and nitrogen. Figure 2 shows the setup used for this part of the experiment. And in this case, we also use a high voltage source connected to the plasma chamber, a vacuum pump, a pressure gauge, a voltmeter, a multimeter, and the gas supply. If you look at the figure 3, you can visualize better the plasma technique. In figure 3A, we have the atmospheric plasma technique. In figure B, we have the low pressure plasma technique in an oxygen atmosphere. And in figure 3C, we have the low pressure plasma technique in a nitrogen atmosphere. For the results of this experiment, we use Raman spectroscopy. In the left side, in the figure 4A, we have the Raman spectrum of silicon oxide and graphene oxide. And in the right side, we have the Raman spectrum after coating in oxide and nitrogen atmospheres. The Raman spectroscopy results, we observed that both samples exhibit the characteristic bands of GO. The D band associated with defects, and the G band related to the sp2 vibration mode of carbon. In an oxygen atmosphere, the D band intensifies, indicating an increase in defects and possible oxidation. In a nitrogen atmosphere, the spectrum suggests a partial reduction of the GO. Then we also use the Raman for take some micrographs. The Raman micrographs confirm these trends. In oxygen, the surface shows larger, indicating a more disordered structure. In nitrogen, on the other hand, the aggregates are smaller and the distribution is more homogeneous, suggesting better dispersion of the material, and also we have a darker aggregates. With this work, we can conclude that plasma technique modifies the silicon oxide surface, forming a GO coating. The type of atmosphere is in the plasma has a direct effect on the structure and morphology of the graphene oxide, allowing its degree of reduction or oxidation, and therefore its properties to be fine-tuned for specific applications. Finally, I would like to acknowledge the technical support of Fermín Castillo, Oscar Sosocotla, Juan Angelina Romero, Jairo Radilla, and H. Hinojosa from the Instituto de Ciencias Físicas or the Institute of Physical Science, as well as Pedro Reyes and the Advanced Physics Laboratory of the UMX. And also I would like to acknowledge the city projects 26, 86, 44, 20, 22, 59, 9, and DJPA IN 10-10-25. I would like to thank Cecilia for the postgraduate scholarship support I received for my master's studies. And finally, at the end, you can find some references of this work. Thank you very much for your attention. And if you have any question, you can send your questions by mail. You can find my mail at the beginning of the poster. And thank you very much for your attention. Have a nice day.